Welcome to the Woodward Governor Company's engine room. We have 3 diesel engines that we use for testing and development of new controls here. A 3306 Caterpillar engine with 155 kW capability will be used to help demonstrate the installation and adjustment of our 2301A load sharing and speed control. The 2301A load sharing speed control can regulate speed and load for a variety of prime movers. This includes gas or diesel engines or steam and gas turbines. The 2301A has standard features of isochronous or droop speed control, isochronous load sharing, a wide dynamic adjustment range, and forward or reverse acting models. The power supply in the 2301A will eliminate ground loop problems. The input voltage for a 2301A will vary from 20 to 45 volts DC. We have a start fuel limiter added onto the 2301A which will lessen your emissions on startups. For smoother acceleration from idle to rated, a linear ramp has been added. The 2301A is also more resistant to EMI RFI interference. Other equipment we'll be using to help demonstrate the 2301A today will be on the engine we have a EG3P actuator. We simulate your switch gear with 3 switches. We have a circuit breaker auxiliary contact, close to override failed speed signal, close for rated. We have a speed trim potentiometer. We have a Hertz meter which will vary from 55 to 65 Hertz. We use an analog meter. We have a power supply which will provide the input power for the control. We have a digital meter. We have a function generator. And we have an electronic counter. We have a consolette that sits here. The consolette is wired to the engine. And from the consolette we can start and stop the engine. We have a resistive load bank located out behind the building which we can use to load the engine. With the wiring we can get our engine speed signal from the consolette here, and we can get our actuator signal from here. Over on the far right we have our potential and current transformer signal. These come from the generator and will be used for our load sharing section of the control. Today what I'm going to be mentioning to you mostly will come straight out of our 2301A electronic load sharing speed control manual. So if you have one of these manuals, make sure you read it before you get ready to install and adjust your 2301A. Now you're ready to install your 2301A control. A location must be found to install this control. The location considerations for this are low vibration, adequate ventilation, avoid places where moisture can get on the control. You need a good temperature range. Extreme temperature range for a 2301A is minus 40 degrees centigrade to plus 85 degrees centigrade. The 2301A is not designed to be mounted on the engine, so please do not mount this control on the engine. Once a location is found, you are now ready to start wiring to the control. So we're going to start wiring to the control. We're going to hook up our PTs and CTs first. I have my wiring coming out here, and my PTs and CTs are all in a bundle by themselves, and I have them labeled, and they're also color-coded. I'm going to start by connecting up. You have to make sure you don't use terminal 0. So make sure that you start hooking the A-phase potential transformer to terminal 1. The potential transformers are designed to run at a minimum of 90 volts AC and to a maximum of 240 volts AC. So make sure the signal you're providing us falls within that range. Once we have the potential transformers hooked up, we'll go to the current transformers. The current transformers now, we do not provide burden resistors in our control anymore. The burden in our control is really a dead short. We use a current transformer, which we jumper a 16-gauge wire through to measure the current through the CTs. That gives us better isolation than in the past. Also, your CTs, you can have a lethal voltage across your CTs if you have one side disconnected from your terminal block when you're loading the engine. So you want to make sure both of your CTs are connected up before you start the engine and run. Of course, we have phase A, B, and C CTs, and later on in the demonstration I'll show you how to check to make sure you have your CTs and PTs hooked up correctly, and if you don't, I'll tell you how to find which ones are hooked up incorrectly and get them straightened out. So now, once I get this last one hooked in, we'll go on to terminals 10 and 11, which are our load sharing lines. First thing I want to point out about this is we should have shielded cable coming to terminals 10 and 11, with the shield connecting to terminal 12. We are not using the load sharing lines today, so I will not have any wires hooked to these, but the 2301A provides a relay inside the control which will now allow you to hook a 2301A load sharing lines directly up to another 2301A load sharing lines. And the shields can be hooked to both also. Now if you're going from a 2301A control to some other type of electronic speed control, do not continuously run the shield to the next control. Our shields are shown on here for our shielded pairs where they should be connected and if they should be. And if you connect the shield to the 2301A control, at the other end of that cable, that shield should not be hooked to anything. The shield will be terminated here at our control. And we point out very clearly on here where we use those shields. Terminals 12 and 13 are also your load gain signal. This is where you set up so at maximum capability, you set up your load gain so that each unit will load share proportionally. Terminal 14 now is a new one. It's called a circuit breaker auxiliary contact. And what this does, it also provides you with an isochronous or droop control. If no voltage is hooked on terminal 14, you're going to be in droop control. And what we want the customer to do here is provide a relay or a contact of some type that will close when you go onto the load bus or your paralleling bus. Once on that load bus, that will close and that will put the 24 volts or whatever your input voltage is on terminal 14 to put the control in isochronous speed control. That will also close this relay in your load sharing line so you can isochronously load share. We show just a contact here. You can also, on page 8 of the manual, it points out to you how you can put an isoch droop switch in line with that circuit breaker auxiliary contact. So if you do want to run two engines in droop against the utility, you may. You won't always go in isochronous. And then the one other thing I need to point out about terminal 14 is if no voltage is on terminal 14 and you're in droop, if the droop pot is turned fully counterclockwise, you're calling for 0% droop, which is the same as running in isochronous. So if you keep your droop pot turned fully counterclockwise, you will be running in isochronous. Now, as I showed you earlier in my switch gear, we have a switch that I'm going to use to simulate terminal 14. Let me hook that up here. So I'll be able to close that switch and put voltage on this. I'll simulate a breaker closure. Terminals 15 and 16 are our power supply input. with terminal 15 being minus. As I told you earlier, the power supply input can go from 20 to 45 volts DC. The power supply we're using today, I have one of my wires here coming in. I'm going to hook up terminal 15. And before I hook up terminal 16, I want to go ahead and explain terminal 17. Terminal 17 is open for minimum fuel. Now, open for minimum fuel should not be used for an emergency shutdown. It can be used for a normal shutdown of your engine in your installation. But today, we already have a shutdown for the engine, so I won't be using terminal 17. So what I'm going to do, I'm going to use this little jumper here. I'm going to jumper terminal 16 and terminal 17 together so that terminal 17 is always high and will not come into play today in this demonstration. If you don't have anything on terminal 17, you will not be able to start your prime mover. So if you don't have terminal 17 jumpered to 16, make sure you have it going to some contact that will provide an input voltage to it so you can start the engine. Terminal 18 now is our close to override failed speed signal. I again have a switch in my switchgear for that. Now, that is a momentary switch. You only want a momentary switch for your close to override failed speed signal. Terminal 19 is closed for rated. This will let you go from idle speed up to rated speed. I have a switch for that. What I do on all these terminals, 14, 17, 18, and 19, they need to be provided with the positive side of the input voltage to control them. So as soon as I put a voltage on terminal 19, we'll ramp up to rated speed. Now we're up to terminal 20, and 21 is our actuator input, with 20 being positive. Now you can see that's a shielded pair with 22 being the shield for that. So I want to make sure I terminate the shield for my actuator at the control here. So let me hook up. And 22, and before I hook 22 down, my next ones, 23 and 24, are for speed trim or a jumper, or it can be a digital reference input. But that shield also goes to terminal 22, so I'll have two shields on terminal 22. So let me grab this. I'm using a speed trim pot today. Now the main thing you remember on your speed trim, if you're not using a speed trim potentiometer or a digital reference input, you have to have a jumper on that input or you will not be able to start the engine also. I'm using for my speed trim potentiometer a 100 ohm potentiometer, and I have it set in mid-range. Terminals 25 and 26 are your SPM synchronizer input. We are not using an SPM synchronizer today, so nothing will be hooked to that input. But if you do, that's also a shielded pair with a terminal being terminated on terminal 27. Then our last input will be our speed signal input. For our speed signal today on the Caterpillar, we're using a magnetic pickup. I have that coming out here. And 27 is also the shield for that shielded pair to be terminated at the 2301A. So now we have all of our wires connected up to the control. For the visual inspection, you want to check on the engine, the actuator linkage, to make sure that it moves smoothly. Check the magnetic pickup on the engine to make sure that it's turned in close enough to the gear that you'll get a good signal. Check all the wiring to the control to make sure no wires are loose or broken. We're going to start by presetting the droop potentiometer. I want to set my droop potentiometer full counterclockwise. My load gain potentiometer I want set at mid-range. Now you can see these pots are recessed underneath the cover of the control. And that's for when you use your screwdriver or tweaker, you're going to touch the side and that will discharge any static you have on your tool to make sure you don't static a component through the potentiometer. And that's why these are recessed, not just to make them harder to get to. On each dial here, I want you to notice they're labeled 0 to 10. So that should help you in your setups of them. The low idle speed potentiometer, we're going to preset full clockwise. The ramp time potentiometer, we're going to set to maximum amount of time, which is full clockwise. The actuator compensation potentiometer is a new potentiometer we didn't have on our old 2301 control. This will allow you to run on a variety of prime movers. We want you to set this actuator compensation at 2 on your 0 to 10 dial if you have a diesel engine, small gas turbine, or fuel-injected gasoline prime mover. We want you to set it up to 6 on the 0 to 10 scale for a carbureted gas or gasoline prime mover, medium to large gas turbines, and steam turbine prime movers. So we're using a diesel engine. I'm going to set this up for 2 on the dial. You should not have to adjust that actuator compensation again once it's preset for your prime mover. The gain potentiometer, I'm going to set it mid-range. And the reset potentiometer, I'm going to set at mid-range. Our rated speed potentiometer, now if it's already preset, if you know this is already preset for the speed of your prime mover, do not adjust the rated speed potentiometer. In this case, it is not, so I'm going to turn my rated speed potentiometer fully counterclockwise. This is a 10-turn potentiometer. So let me turn it until I hit a stop going counterclockwise. The start fuel limit potentiometer, I'm going to set up for full clockwise. So now we have preset all the potentiometers on the 2301A control. Now we're ready to provide power to the 2301A. And let me hook up my digital meter here to the input voltage, terminals 15 and 16. What I'm checking for here is that I have the correct voltage and that I have the correct polarity going into my control. I'll turn on my power supply. My digital meter reads right around 24 volts. So I can run anywhere from 20 volts to 45 volts DC, so I'm just going to leave it set there at 24 volts. The next thing I need you to check out, I want you to put the positive side of your meter on terminal 20, the negative side on terminal 22. This will check out an internal power supply voltage. It should be 18.9 to 21.6 volts. And our digital meter here shows 19.3 volts, which is acceptable. That tells me my internal supply is working in the 2301A. Now the last check you need to do before you start up is I want to make sure my speed signal input is correct. I want to make sure I'm getting enough voltage there so I can start. So I'm going to hook up to terminals 29 and 28. I need to go into the AC mode, and I'm going to go down to my 20 volt scale. Now what I'm going to do here is just crank the engine and then stop it. Now I'll see this voltage go up. And I need to be above 1 volt RMS cranking when I'm at cranking speed to start the engine, or the 2301A won't see the signal. So I'm going to start it. I went clear up to 9 volts RMS. So I got plenty of signal coming from my mag pickup. So that tells me my mag pickup is all ready to go. So now I'm going to unhook my meter. I'm going to connect up my analog meter. My analog meter I'm going to connect up to my actuator voltage. The main thing here is once I get started, there's a good chance I'll be unstable. I'm going to have to adjust my gain and my reset potentiometers to adjust that instability out. And by using your analog meter, you can adjust it till you get the meter smooth. It's easier than looking at a Hertz meter or trying to listen to the engine and smooth it out. So let me go terminal 20 positive and terminal 21. You can see we're reading 0 volts on the meter. So now I'm ready to start the unit. The rated speed pot is turned fully counterclockwise. We don't know what speed we're going to run at, so I'm going to have to start the unit and turn my rated speed pot fully clockwise. Now I need to make sure my close for rated switch is pushed in, so I start up at rated. So now we're ready to go. I'm going to push the start button. I'm going to turn my rated speed pot clockwise. We'll start up at a real low speed, and then I'm going to use my Hertz meter to see when I finally get up to 60 Hertz. So I'm going to start the unit. It started up at a real low speed. Now I turn my rated speed potentiometer clockwise. You can hear the engine picking up speed. We're on the Hertz meter now and set it up for 60 Hertz. So now my Hertz meter is reading 60 Hertz and we're controlling the engine. And the engine came up stable, so my analog meter just shows what the no load voltage is on the actuator. We're reading just under 2 volts reading on the analog meter. So now I'm going to want to adjust my gain and reset. Since we're stable already, I still want to show you how to adjust your gain and reset potentiometers for your prime mover. Now I'm going to turn the gain pot clockwise until I get an instability. Let me turn my analog meter down to the next scale so it comes up more in the middle. So now I'm going to turn my gain pot till I get my analog meter to go unstable. Then I'm going to back my gain pot counterclockwise till I'm stable. Now I want to turn my gain potentiometer will cause a momentary speed change. So to minimize this speed change, I'm going to turn the pot very slowly. As I turn the pot, the analog meter shows you that we are now unstable, and you can hear the actuator. Let me back off. Okay, now the analog meter shows that we're stable. Now I'm going to do the same thing with the reset potentiometer. I'm in mid-range right now. I'm going to turn it slowly clockwise until I go unstable. The reset potentiometer will not always make you go unstable fully clockwise. As right there, I'm fully clockwise, but I'm not unstable. Well, now, what the reset will do for your response time of the prime mover is when you go off a speed, it's going to keep you from coming back and overshooting that speed. It's going to pull you back into speed smoothly. The gain will catch your off speed, And the reset will decide how quickly you come back and set up at your rated speed. So what I know with that reset pot turned fully clockwise, once we go off speed, it will be really slow coming back to speed. So I'm going to set this up to mid-range again, or number 5 on the dial. Now to show you how this works, you can bump your actuator linkage and see how quickly it responds to come back to stable setting. But instead of doing that, here I have the capability of using a resistive load bank. So I can actually put load on my prime mover. I can watch my Hertz meter to see the reaction time of the Hertz meter. Now I need to close my load breaker. And now I'm going to start adding load to the prime mover. And if you watch the Hertz meter, you'll see a slight off speed back to 60. That's a small amount of load. That's a 25 kW load step. Now I'm going to put on a 50 kW load step. And that's pretty quick and smooth the reaction time. You see we go a hair off speed and back to 60. Now the Caterpillar is turbocharged. So there is a slight time delay in the turbocharger getting going. So a little bit of that off speed is from the turbocharger. But you can see we're running at 60. Now if I take the speed off, the load off, I mean, the speed will change and come right back to 60. That's very smooth. That's probably very acceptable to leave my settings at those points. But what I'm going to do to demonstrate for you, I'm going to turn my reset pot up to 8 on the dial. On the dial of 0 to 10, I'm now set up at 8. Now I want you to watch the Hertz meter again as I put the loads on. I'll put on the 25 kW load. Now the 50 kW load, it takes a lot longer to come back to the 60. And that's what the reset will do for you. It's going to take longer for it to come back, so that's taking too long. I'm going to turn my reset back to number 6 on the dial. I'm going to go ahead and take my load off. See, that comes back nice and smooth. It's still a little slow. I still like it best set right at 5, so I'm going to set my reset back up to 5. I'm going to leave it that way. So now my gain's set just past mid-range, and my reset is at mid-range. So now we're running at 60 Hertz. We showed you how to stabilize your engine once you're up and running. Now what I need to do is I want to shut down the engine. I want to show you how to set up the speed of the engine using a function generator and an electronic counter. So let me go ahead and go and shut down the engine. I'm going to leave it closed for rated. I'm going to leave my analog meter hooked on to my actuator voltage. I need to go ahead and turn my rated speed potentiometer back to fully counterclockwise position. Now what I want to do is I have a function generator available to set up my speed. So I'm going to use a function generator to go in instead of my mag pickup, to go in to simulate a mag pickup. And by using my analog meter, I'll be able to find out where the 2301A wants to take control. Let me get over here. I have a function generator here set up, and you can see my electronic counter is reading 4678. And I want to go ahead and I'm going to hook this on for my speed signal input. I need to unhook my speed signal input that's there, I guess one side of it. So I'm going to unhook terminal 29. Now I'm going to hook up the function generator in its place. My actuator voltage is still low. And what will happen here, I'm set up for my rated speed, which is 4678. I need to explain to you how I figured out what the frequency is that the 2301A controls at. And what you need to do is, we're running off a mag pickup. You need to know the number of teeth that are on the gear that you're having the mag pickup hooked to. You take the number of teeth times the speed of the engine, in this case it's 1800 RPM, and then divide that by 60, and that will tell you the frequency your engine will run at. And to show you that, I got a calculator here. The number of teeth on our gear is 156 teeth. So we're going to take 156 times, it's an 1800 RPM engine. Then I'm going to divide that by 60, and that gives us our 4,680 hertz. So that's how I figure out what the function generator should be feeding into the speed control. Now that we're feeding that signal in, you need to make sure on your function generator that you have your output level above 1 volt RMS. So make sure that, don't have your output level turned fully counterclockwise on the meter function generator. Now what you're going to be looking at here is you're going to be using your analog meter, and as I turn the rated speed pot clockwise, as we hit the point that the 2301A wants to control at 4680, our actuator voltage will integrate high. So let me go ahead and start turning my pot, which I set fully counterclockwise. So I'm turning it clockwise, and as soon as I go by the point that it wants to control, the voltage goes high. The voltage integrated high, so now I know I'm close to the point, go backwards. Okay, now it integrated low. Now I want to turn it slowly now, try to get it where that integrates very slowly toward, okay, there, it's integrating very slowly toward 8 volts. So now that tells me I'm set up very close to 4680. I'll probably still have to tweak in the frequency once I get up and running. But for now, this tells me I can go ahead and start, and I know I'm going to control at 4680. Well, since I can control at 4680, I might as well set up an idle speed. I want to run at an idle speed on this. I have my idle pot fully clockwise right now. I want to figure out my idle speed, which I'm going to set for 1200 RPM here, so I can quickly take 156 times 1200 and divide that by 60, and that tells me I want to set my idle speed for around 3,120 hertz. So let me go over my function generator, set it right around. You don't need to be super accurate on this, you just need to be close so you know where you're going to control at. I'm going to set it for around 3,100. Okay, now once I'm set just a little bit above 3,100, I need to come over now. I'm going to open my closed for rated switch. The voltage stayed high. That tells me my potentiometer set too high, so now I'm going to turn my low idle speed potentiometer counterclockwise until that voltage integrates down. Okay, the voltage integrated down. I'm going to turn it back up, try to get it to where it moves real slowly. Okay, that's going to be close enough for idle. And you have to remember, the idle potentiometer is just a one-turn pot where you have a 10-turn rated speed pot. So it's going to be harder to set up your idle speed to where it's barely creeping up in voltage. So anyhow, now my idle speed set for just above 3100 hertz. I'm going to disconnect my function generator. I need to reconnect up my speed signal. We're going to start up in idle. We're going to start up around 3119. My power supply is turned on. So now as I hit the start button, we're going to come up to idle speed. Engine starts up. We're running at idle speed. Should be around 1200 RPM. Doesn't show up on the Hertz meter. We're not high enough to be on the Hertz meter. So now, that shows you how I can set up my speed with the function generator. I need to talk about my ramp time. Once I hit this switch now, the ramp time is set for full or maximum ramp time, full clockwise. The control will linearly have a smooth acceleration from idle to rated speed. So if you watch frequency meter, I close for rated. You can hear the speed in the background picking up slowly. If you watch your Hertz meter, we'll come right in and smoothly come into control at 60 Hertz. Now, if you're not right at 60 Hertz at this point, you can use your speed trim potentiometer to go ahead and tweak in that speed. If I turn my potentiometer clockwise, I'm going to speed up. If I turn it counterclockwise, I'll slow down. So I'm going to set this so I read 60 Hertz exactly on my Hertz meter. That's where a speed trim pot can be used. Now I showed you a maximum ramp time. The maximum ramp time is 10 seconds. So let me go ahead and go back down to idle speed. And now I'm going to turn my ramp time potentiometer fully counterclockwise. Okay, now this time when I hit my close for rated switch, we're going to go up to rated speed instantly. So if you watch the Hertz meter, when I close my switch, we'll come into 60 Hertz immediately. Very smooth but very fast acceleration. So now we've set our idle speed, we've set our ramp time. We showed you how to adjust your gain and reset. We showed you how to set your rated speed pot. One more comment on the gain and reset potentiometers. Not always do you want optimum gain and reset settings. If you're running in a large system where you have 2, 3, 4 engines load sharing, setting each engine at optimum response time could cause an instability once you start putting the units together. So you might need to crank off on your gain a little bit there in a large system. So just a word to the wise there. If you're having a problem once you hook engines together, cut back on the response a little bit of each unit. One thing I haven't mentioned yet is our start fuel limiter potentiometer. With this added feature, we can set up so instead of calling for maximum fuel on startups, you can limit that amount of fuel you're calling for to get smoother, quicker startups. Also, it will allow you for less emissions from your prime mover control. To set up your start fuel limit, you need to measure your unloaded actuator voltage or no load actuator voltage. And I'm hooked up here on my analog meter. Let me go ahead and switch over to my digital meter real quick here. Need to go on DC, of course. Hooks up pins 20 and 21. Okay, read 1.8 volts on my actuator voltage. So what you need to do, you want to set up your start fuel limit for 1.8 volts plus 30% of that voltage. So using my calculator again, I take 1.8 times 0.3, then I need to add that into 1.8, so plus 1.8. So I want to set up my start fuel limit for 2.34 volts. Now, how do you do that? Well, let me go ahead. I need to stop my engine, so I'll go down to idle speed. Now I'm going to stop the engine. Now to set this start fuel limiter up, the actuator voltage goes to 0 when the engine is stopped. So what I need to do, I'm going to use my close to override failed speed signal switch. And once I push that in, you can see my actuator voltage went high on my digital meter. Now it's a momentary switch, so I need to hold it in. Now as I turn my start fuel limit potentiometer counterclockwise, that voltage is changing. I want to set that up for 2.34 volts. Or right around it. You don't need to be right on it. So now I'm close to 2.34 volts. So now I'm going to let up on the close to override failed speed signal. Now I'm ready to start up again. So this time, start up. Let me show you, put on my analog meter, show you the actuator voltage again. It won't call for maximum fuel now. It's going to call for where we're holding it on the start fuel limit. I want to point out, once we get started, the start fuel limit circuitry is overridden. I'm going to go ahead and start up at idle speed here. I hit it. You can hear the engine's trying to crank over. We're calling for voltage and it just isn't getting enough fuel. So in this case, 30% wasn't enough. It just wasn't enough fuel to start this prime mover. So what you want to do then is you want to hit the start button and then slowly turn your start fuel limit potentiometer clockwise till you get enough fuel to start. So let me go ahead and get set up here. You're going to hit the start button. I had to turn it up just a little bit there. The engine started. We're running at idle speed now. If I close my close for rated switch, we ramp right up to 60 hertz. So let me show you that again. I'm going to start at rated speed now. I'm going to stop the engine, then start it back up to rated. And you'll see with this start fuel limiter in, we're calling for less fuel, saving you fuel, and then your emissions will be a lot less. And we'll start up smoothly up into and come right into 60 hertz. Let me go ahead and start it. And the unit comes right up and controls at 60 hertz. It makes it easier for our control to keep from overshooting 60 hertz because it's not getting all that extra fuel early. So that's the start fuel limit. Now that you're up and running, let me go ahead and load the engine. Turn my analog meter up. You can see we stay running at 60 hertz. That start fuel limit is out of the picture completely now. So now we're running at 60 hertz. Let me go ahead and unload the unit. Now I want to point out droop and load gain. To set up your load gain voltage, you need to have load on your engine so that the CTs are giving us a signal. Now, in your situation, you might not be able to have a resistive load bank to load up the unit fully. So if you can get a percentage of load of what you know is the maximum load of the engine, get a percentage of it, and then you want to set up your load gain signal for a percentage of what you would set your load gain voltage at for your maximum load. So at 100% load, if you want a load gain voltage of 6 volts, and you only have on a third of that load, you want to set up your load gain voltage for 2 points at that point. So let me point that out here. I'm going to use my digital meter, hook up to terminal 12 is minus, 13 is plus. Droop pot is set at 0, so we'll be running at 0% droop or isochronous. That's what we've been running at so far. Now I'm going to put on 50% load on the engine. I'll put on 33%. So now on the engine we're carrying 50 kW, which is a third of rated. I want to make sure that once I get up to 100% load, I'm reading 6 volts at my load gain. My load gain is set at mid-range. So let me go ahead and turn this voltage up. I turn my load gain voltage fully clockwise. I can get just under 3 volts out. So now I'm going to back this off and set it for 2 volts. So now I'm set for right around 2 volts on my load gain. Now I'm going to put on the rest of the load, and when I get up to 100% load, my load gain voltage should read right around 6 volts. Should be very close to 6 volts. Put on the last load, we're up to 100% load. We're reading a little bit high, and that's because these resistive load banks aren't exactly equal. So when I said I was at a third load, I was a little bit underneath that. But this should get you very close for your load sharing lines. So now let me go ahead and tweak that down so it reads 6. So now we're reading right around 6 volts on the load gain. Now if I take all my load off, that load gain voltage will come back down to 0. Now this brings us to a point of phasing corrections for your PTs and CTs. Now with the engine running, we have 120 volts AC from A phase to B phase, B phase to C phase, A phase to C phase. But if we can set this up, but you could still have one of your CTs turned around, reversed, or you could have them hooked up incorrectly. Now, a very simple test for that is when you're at this point, you've set up your load gain voltage. You need to stop the engine. So let me go ahead and stop the engine. Now what I need you to do, I need you to connect terminal 5, which is the A phase minus side of the CT, to terminal 4. So what we're doing, we're going to short out the A phase. Let me disconnect that. Loosen up terminal 4 here. Now what this is doing is just eliminating the A phase CT. So now that voltage, the CT current that the control was seeing will be 1/3 less because we're missing one of the 3 CTs. So now when I start up again and load up the engine, my load gain voltage should only read 1/3 of what I set it up for when all 3 CTs were hooked up. If it does, that tells me my CTs were hooked up correctly to begin with, and that I can go ahead and hook up the A phase back to terminal 5 and leave it alone because my CTs will be correct. So let me go ahead and start the unit. Go ahead, start the unit, come up to 60 hertz. Now I'm going to go ahead and load up the unit. and watch my load gain voltage. So as I load up, I should measure around 4 volts, and I do. I measure just above 4 volts. So that tells me, yes, my CTs were hooked up correctly, and so I can go ahead, stop my prime mover again, and hook that A phase back up. Want to point out to you, if this voltage does not go down by 1/3, say it went down by 2/3 and you were only reading 1/3 of your what you set up the load gain for, on page 16 of your manual, you need to go through the phase correction procedure. Phase correction procedure will take you through, and through the many steps in it, you'll be able to set up all your PTs and CTs correctly if you do have a problem. So let me go ahead, take the load off of this unit. I'm going to go ahead and stop the Caterpillar engine. And now I'm going to connect terminal 5, back up terminal 5. So now we'll be running normal again on our CTs. So now I can start up the engine. Come right up to rated speed. Now as I load up, you'll see that we're going to read just above 6 volts at full load. Now that we're set up for full load, went over load gain voltage, need to talk about droop. I haven't used my circuit breaker auxiliary contact yet. Right now that's open, and we've been running in droop, except it's been 0% droop. And you'll see if you watch your Hertz meter, as I start turning my droop potentiometer, turn it clockwise, we're going to decrease in speed. So I'm going to go ahead and set my droop up for 57 Hertz. So now my droop is set up for 57 Hertz when I'm at full load. So let me go ahead, start taking load off, and you'll see we'll start increasing in speed. I put it back on, we come back down to the speed. So I take a load off, my load gain voltage comes down, my speed will go back up. I'll take some more load off, load gain voltage decreases, the speed increases. Take my last 2 loads off, load gain voltage is down to 0, and we're running at 60 Hertz. So that's droop. We're set up for a 5% droop right now. Now let me go ahead and close my circuit breaker auxiliary contact. This will be like you just closed to a load bus. You're going parallel with another unit. You close the breaker, that put 24 volts on terminal 14. Excuse me. Now we're on isochronous. That relay I was talking about in the load sharing lines is now energized. So if there was another unit online, they could be talking to each other through the load sharing lines. So now let me start loading up the engine. If you watch the Hertz meter, we're going to stay running at 60 Hertz. We're in isochronous now, so we won't droop off. If I open up that circuit breaker auxiliary contact, then we're back into the droop mode. So that's how that functions. And with the droop you set up for whatever amount of droop is necessary, in your application. So now we've covered the whole control. Let me take the load off here. We've talked about droop. We showed you how to set up the load gain. We showed you how to phase your PTs and CTs. Terminal 14 now, the thing I didn't show you was a contact in series with the switch. But now for your application, that should be simple enough to figure out, knowing that once terminal 14 goes high, you're going to be in isochronous. And if you need to be in droop, you have to have that open. So that shows all the adjustments on a 2301A control. And if you have any questions, refer to the manual or please contact the Woodward Governor Company in Fort Collins, Colorado.